You're going around the moon in September of 2025, currently scheduled for that. You'll be the first Canadian to do so. You just saw a real special moment. That's another one. What are your thoughts on getting ready to take that big trip?
You can imagine I have a lot of thoughts about Artemis 2 and what Reed, Christina, Victor, and I are getting ready to undertake. But if I have to boil it down, a lot of it comes down to pride. I'm really proud of humanity for taking on these big challenges. I'm really proud of the United States for their leadership, for creating this opportunity where other countries can express our genius, bring real contributions to the program. And now Canada is going to be the second country in the world to send a human into deep space. And it's got nothing to do with me. It has to do with the genius that the world is sharing. I just love that.
That's amazing. Want to mention real quick, we are in full totality up at Tupper Lake, New York, not far from here in northeastern New York. We're here in western New York where light is continuing to shine.
Look at that. I'm geeking, man. I'm not gonna lie. Like, this has me really. Look at my phone, Vato. It looks like a black hole. Come look at my phone. Look at this.
Oh, damn.
Look at that.
I can't do that, Vato.
Look, I can get closer. No, that's the fastest way. Or for this.
Damn, that's nice.
Isn't that insane? And I feel really bright.
That's it with me. I gotta look at that.
Dude, this is so cool. I'm geeking. Oh my god.
My God.
Look how dark it is.
The stars are coming out.
Oh my.
We're not there, but I feel the energy just watching it.
Yeah, so this is because of the craters and the peaks and valleys of the moon, we're seeing the last bits that are just getting through, and now we're getting to totality. This is great. So you're starting to see those pink fingers out there kind of sticking out.
Wow. So again, totality here in Mazatlan, Mexico, the first community in North America to experience the moon completely eclipsing the sun. And if you are in Mazatlan right now, it is now safe to remove your eclipse glasses for the next 4 minutes. That's right. We're not there.
Oh my god.
Miles per hour, so that is a fast clip. If you're in the path of totality, really take full advantage of those few fleeting moments to observe this moment. If you're not in that path of totality, or if you missed it, hopefully you didn't miss it because we've been tracking it all day here showing you. If you did miss it, I'm going to zoom way out here and show you what to keep an eye out for in the future. So this is going to be the eclipse path in 2045. We're going to come through parts of Montana into North Dakota in 2044. 2045 is the next big eclipse across America. That's actually going to come, oops, I didn't draw here. There you go. That's going to come all the way from California into parts of Florida there. That is in 2045, so a long time to wait. So really take full advantage of those fleeting moments to be able to observe this moment. I'm going to click on Burlington here, who are also in that path of totality, experiencing that right now too. So just an incredible moment to really see all of this. And Tupper Lake, again, they're still, I think, experiencing that last fleeting moment there. That is just moving off. You can see that is officially now moved off Tupper Lake. Really a fantastic shot. They have that now, that diamond ring effect, that really beautiful shot there. This is, again, such a quick moment, and this doesn't happen very often. It's really a once-in-a-lifetime moment, so take full advantage of this. You can see just how close we are now to Holton, Maine, who are our last stop of the day on our NASA coverage here. This is then going to continue on into parts of Canada and beyond. Holton, Maine, they had some snow past couple days. It seems to have cleared up quite a bit more for them. Really hoping that that holds out for them. They are expecting a duration of 3 minutes and 20 seconds to be able to observe that totality at 3:32:05 local time. Really excited to see that view. You see that shadow creeping so quickly up to them up there. So Let's check in with Angelique, who is up there in Holton, Maine. Hopefully it's beautiful weather for you. How's it looking up there, Angelique?
James, it is looking awesome up here. We are just a few minutes away from totality. You can hear people announcing it in the back, and people are getting excited, as am I. And here to share in all of that excitement with us is actually Dr. Eric Smith, the program scientist for the James Webb Space Telescope. Eric, it's so great to have you here.
Oh, it's great to be here, Angelique. This is really exciting.
Eric, is this your first eclipse?
This is the first totality I'm going to see, so I am super psyched, and I am delighted to be here in Maine to experience it.
Yes, and so we've actually been kind of watching as it slowly gets closer and closer, right? And what are we're starting to feel it getting kind of cooler. We're seeing the shadows change.
Yeah, we're seeing the light is definitely different from when the sun sets and the shadows get a little diffuse. Here they're still sharp, but the light is diminishing. Your brain tells that something different is happening.
Something is definitely up. So, speaking of up, that's where the James Webb Space Telescope is. And what's interesting about the telescope is that it actually can't look directly at the sun, just like we can't.
Yeah.
Can you tell me a little bit more about why that is?
Sure. We designed Webb to look for very faint things in the distant universe, so it's very sensitive for very faint things. Of course, the sun is very bright, and so we had to make sure that it could never look at the sun. We use solar power to power the spacecraft, but the telescope can't look at the sun.
That makes a lot of sense. Now, as it's starting to get a little bit closer to all of the cool phenomenon, the Bailey's beads, the diamond, let's go ahead and put on our glasses.
All right.
So that we can look up and continue chatting. Wow.
Just a little tiny
Just a little bit left. That is incredible. Wow. So, Eric, I have a couple more questions for you. Another thing that I was wondering about is how we can use actually eclipses to study exoplanets, which are planets outside of our solar system, using, I think, the transit method. Is that what that's called?
Yeah. Right now, during an eclipse, the moon...
Sorry, you can hear everybody getting excited. We're getting very close to totality here.
The moon is transiting in front of the sun just the way planets that orbit around other stars transit in front of the star. So Webb can look at those exoplanets and use the transit just like we're staring up at the moon transiting the sun.
Gotcha. And so a transit is, like you said, literally just when something crosses in front of something else. That's
right,
transit.
yeah.
Okay. Very cool. So throughout the broadcast, we've actually been able to see the eclipse through different telescope feeds. Can you tell me a little bit about what the difference is between, actually, we're going to go ahead.
Oh, here we go.
We're getting really close. Oh my gosh, it looks like just a few more seconds until we are in complete totality. Oh my gosh. 5, 4, 3, here we
2,
go.
1.
You can hear everybody cheering. This is incredible. So let's go ahead and take off our glasses. We are in totality now.
Oh, you can see the coronal spikes.
My God.
Amazing.
That is
Beautiful.
incredible.
You can see a planet in the sky that you couldn't see before.
Oh, wow. And I think, is that one of the, oh gosh, the
there's some drone. There's a drone up there in the sky, too.
Oh, my goodness.
Oh, wow.
It's incredible. The rays that you can kind of just see coming off of the corona.
Yes, yeah. Stunningly beautiful.
Yeah, that's
Yeah.
got to be one of the most amazing things I've ever
And
seen.
you can see the gradation in the sky color
Yes.
down to the horizon,
Oh
too.
my goodness.
Yeah.
I am seeing a bit of that 360-degree sunset.
Yes, yeah.
That is really cool.
It's amazing. Even though we're in the total shadow
Right.
here, there's still the corona is still pretty bright.
It is incredibly bright.
You could read by the light of the corona.
I think I would have some trouble reading, but I probably could. I could technically read something. So, Eric. Oh, and actually, we have the International Space Station flying over right now, so they are actually seeing not one, but two views of the eclipse. They're able to see not just the moon passing in front of the sun, but they're also able to see the shadow of the moon passing over Earth, which is absolutely incredible. I mean, I can hardly imagine a view being better than the one we have right now, but if there is one, it's
probably on the space station.
It's from the space station for sure. Wow. So, yes, they're able to take some pictures of that, and that is just incredible. Just incredible.
one of the things they told people to do if you're far away was to hear how nature changed. And it was interesting here. We're, of course, surrounded by a lot of people just to hear their reaction when we went into totality.
It's true. The humans in nature have not gotten quieter, but louder, I would say. But, I mean, you can definitely hear the loudness has a different kind of character to it. There's almost like a, I mean, I don't know if wonder has a sound, but I think this might be it. Yeah.
Hushed awe.
Yes, hushed awe. That's wonderful. And I can see just one little red, I guess, like protrusion coming down
little
there.
red spots almost. I noticed those too.
That's cool. Now there are two.
Yeah.
Wow. That is just so cool.
Yeah, I like the 360 sunset. It's a little hard to see behind us, but it's...
oh, we've got at least one or two drones.
Yeah, some... our robot overlords.
Of course. And so, Eric, I know that, I mean, clearly with the drones, people are starting to get involved in the eclipse, and I know that there are lots of ways that people can actually get involved. One of those ways is with citizen science.
Right.
Do you mind talking about some of those opportunities, how people can actually...
Sure. We had citizen science programs where people could use their cell phones to take pictures during the eclipse. And
we're getting ready to come out of totality.
And here we go. Oh, there it is. Oh, it's peeking out. Oh.
Everybody is cheering. We have just made it to the end of totality. We're starting to see the sun just peeking back out again.
Now just look at the ground, how much brighter it's gotten.
It is already so much brighter. That is so wild. That was probably one of the most amazing, but also fastest 3 minutes of my life.
Yeah.
I wish I could do it all again.
Yeah.
All right, well, that was incredible. Incredible to get to experience that here in Holton. Thanks so much to the city of Holton. And also thank you so much, Dr. Smith, for coming out and hanging out with us and experiencing this wonderful event.
Oh, it was my pleasure, and congratulations to the city of Holton here for doing such an amazing job covering the eclipse. It was amazing. Well orchestrated.
Above and beyond. Yeah. And I want to say, of course, a special thank you to photographer Dave Bowman, who has been giving us these incredible images from the telescope feed, and we're gonna enjoy as the rest of the eclipse kind of ends here, going back in the direction that it came. And with that, we're gonna send it back over to you, Megan.
Alrighty, thanks, Angelique. So, Gina, I mean, what do you think? Like, we literally have just watched the eclipse travel, what, about 2,600 miles?
Going across
Mexico to Maine.
Yes.
In, like, what, about 88 minutes?
That's right. It's
so
fine.
fast.
That 1,900 miles per hour that the shadow's traveling.
I mean, did you have a favorite location?
For me, I think between Russellville and Dallas, just getting to hear some of my colleagues and their excitement too was amazing.
Oh my goodness, yeah, no. So, I don't know, I have to be a little bit biased. We did have some cloud cover here,
we did.
But to see it with your real eyes was just...
And we had that moment, which was...
We did, yes. It was amazing. And so it's really cool too, just to think about how millions of us now have this shared moment of what could be a once-in-a-lifetime event.
It's true.
And so, folks, we have time for some more questions from our viewers. And again, we have another great question from Mackenzie, who's in the 3rd grade.
Okay.
Let's roll it now.
Hi, my name is Mackenzie. I am in 3rd grade. My question is, what is the difference between a lunar eclipse and a solar eclipse?
Thank you for that question, Mackenzie. Okay, let's talk about the difference between the eclipses. Now, the solar eclipse that we had today is when the moon crosses between the Earth and the sun. But we also get lunar eclipses, and a lunar eclipse occurs when the Earth crosses between the moon and the sun. So it's really about where the shadow's going. Today, we have the moon shadow projecting on the Earth. During a lunar eclipse, we have the Earth shadow projecting onto the moon. So that's the main difference there.
That we just saw, too, those incredible views from space,
that's
you
right,
know,
from
to see that second perspective view. And so I've got another question for you right now. It's going to be Eli on Reddit. who wants to know, there are quite a few solar eclipses in the world every few years, so why is this one scientifically interesting?
Okay, so yeah, we do get solar eclipses and lunar eclipses maybe 2 to 3 times a year. However, the total eclipse that happens today, total eclipses are about every 1.5 years, and that is a rare opportunity for us to look at the corona, study the corona in a way that we can't do during the other types of solar eclipses that we have. So
and during the solar maximum.
Exactly, during the solar maximum. So for this one particular, you know, we were talking about the solar activity that we were seeing on the limbs during the totality. Yeah, there's just a bunch going on today for this eclipse.
And so too, right now, we've got another incredible view.
Oh, look at that.
These are live views from space, which is just mind-blowing in general. And now we're also to see the moon's shadow across the Earth.
Wow.
It is just amazing. So, you know, Gina, too, thinking about how many people across North America today witnessed this one moment, it's a good reminder that humanity has been experiencing these eclipses for centuries. And, you know, there are different meanings for these events in different cultures. Let's check in with Joy in Dallas to learn more about indigenous astronomy. Joy.
Hi, and welcome back to Dallas, Texas. I'm with Dr. David Begay. He's an indigenous astronomer and also a member of the Navajo Nation. David, thank you so much for joining us. So when people think about science, they might be thinking of Western science. So David, how does that relate to indigenous science, and what did the total eclipse mean to the Navajo people?
I think the knowledge on the eclipse goes way back. From time immemorial, I'm told by my elders. And they knew that when you look at the sun directly, you can damage your eyes permanently. And so they knew that about the danger of looking at the eclipse with the naked eye. So people were encouraged to go inside to ensure that people weren't looking up, especially the kids. So it goes way back. And as far as eclipses, it's a time of renewal, the sun alignment with the moon and also the earth alignment. The whole cosmic cycle goes through a regeneration process. It revitalizes the process. And so it's a gift that goes on. For many years, over and over. It's a cycle. And as far as science goes, there's different definition of science.
Thank you, David.
Maybe we can cut it. Yeah.
Thank you. It's been an honor chatting with you. So thank you to everyone here for joining us. Thank you for the Arboretum for hosting us. For this very, very magical moment. This has been an experience of a lifetime and one that I definitely won't forget. So let's head back to Tahira and Gina in Kerrville, Texas.
Thanks, Joy. We're joined now by Jamie Favors, the director of NASA's Space Weather Program, to tell us more about some cool science that launched today during the eclipse. Welcome, Jamie.
Thanks, Tahira.
Hey, Jamie.
Hey, how are you?
Good. And so can you tell us, why did NASA launch rockets before, during, and after the eclipse today?
Sure, so it's really to capitalize on this really unique situation. You know, things like this happen every day, you know, going from daylight to, you know, sunset into, you know, darkness. It happens so quickly that we can make these measurements, one right after the next, to really understand very precisely what's going on in the atmosphere. With sounding rockets, we can do that so quick back to back, the way we can't do with some of the really large rockets.
Okay, so Jamie, how high did the rockets actually go, and what's special about this area of the atmosphere?
Sure, and we just launched the second of those three just a few moments ago, and that's going pretty well so far. These particular rockets are getting about 250 miles above the surface, pretty close to right about where the International Space Station flies. And before you ask, everything's safe. We take care of the.
And it looks like we've got a playback of that right now.
Here
Oh,
we go.
wow.
Perfect.
Can you walk us through this?
Sure. So from Wallops Island out in Virginia, on the Virginia Space Coast. So these rockets have multiple stages to them. So you're seeing one stage burn for a few seconds, then that drops off, and then the next stage will light, to eventually take it all the way up to about that 250-mile mark above the surface to make those measurements in the upper atmosphere.
Wow, that looks incredible.
Yeah.
Oh my gosh. Okay, and so what is that area of the atmosphere, and why do we care about it?
Yes, it's the upper part of our atmosphere. It's called the ionosphere. That's really from a perspective of heliophysics, where we really see a lot of that interaction with the sun and the earth. We care about it because that interaction can change the way our GPS signals work, our communication signals work, and even up a little bit higher, we start to see the influence of the sun actually causing the atmosphere to change its density in a way that can impact the way satellites orbit the Earth as well.
Sure. Okay. Great.
And so, Jimmy, today we've been doing this fun poll, to see who is Team Sun, Moon, and Earth. What team are you repping today?
Well, other than Team Science.
Don't choose the wrong answer.
Well, my bosses would make sure I go for Team Sun today for sure.
Oh, man. Okay. Well, thank you so much again. Thanks, Jamie. And folks, it is time now to say goodbye to our friend, James Traley, who has made sure we've known where and when to look up all day. James, thank you.
Yeah, thanks so much, Tahira. It's been fantastic tracking this eclipse across North America all afternoon with you. If you're still in the path of totality, you might be in a boat somewhere off the Canadian coast taking this all in. I hope you enjoy that view, that fleeting moment. We've made a big journey across. I can zoom out here on our eclipse board. You can see we started all the way down here in Mazatlan, Mexico. We've tracked all the way across and are now, like I said, breezing past Canada now into the Atlantic Ocean. It's been fantastic to track this. And if I turn on the shadow of our penumbra, you can see this highlighted area. Anywhere in there is still experiencing a partial eclipse. So if you're in that partial eclipse area, be sure to have your eclipse glasses at the ready so you can take in that fleeting moment. We just went outside a few moments ago here at Kennedy Space Center to take it in. It's fantastic, beautiful view. It's really cool to see. You got like a little chunk out of the sun there for us here, only about 50% coverage, but still fantastic to see. So really, it's been phenomenal. We've lucked out in general with the weather all of today too. That was the biggest concern I had going into the day here. It's been beautiful views up and down here, and so really fantastic to see this. Really been a lot of fun tracking this with our Eclipse Explorer. A big thanks again to our scientific visualization studio for putting this tool together. But for now, back to you, Tahira.
And here with us now is NASA Chief Scientist, Dr. Kate Calvin. Kate, welcome.
Hi, Kate.
Hi, nice to be here.
So happy to have you back here again. I know we had the pleasure of sharing the stage together for the annular eclipse.
Right.
Now, with today's total solar eclipse, can you tell our viewers what would you say is the #1 takeaway from today's events?
I would say the #1 takeaway is that our universe is beautiful and understandable. We all got to experience this together today. We could predict when it would happen, and we did a lot of science today.
That's great. So speaking of the science that was conducted, how does that fold into kind of the greater science that we're doing with NASA in the future?
Yeah, so we did a lot of science today, and a lot of it really complements science that we do all of the time. So one of the things we were really looking at today was the corona. The moon blocked out the sun so that we could see that part of the sun's atmosphere. But we also have a mission called Parker Solar Probe that's orbiting closer and closer to the sun so that we can study the corona with that. We were also looking a lot at how the eclipse affected Earth. So we had a citizen science project that looked at how the eclipse changed temperatures and clouds. We have a mission that launched 2 months ago that's studying clouds all the time, a mission called PACE. Awesome. It'll tell us more about oceans and atmosphere on here on Earth. And one of the other things we do is we develop instruments called a coronagraph. So the moon blocked out the sun today so that we could see that corona, but we can make an instrument that does that. And so we have an upcoming mission called Nancy Grace Roman that's going to block out the light of other stars so we can see what's flying around them.
Amazing. So much going on for the sun at NASA, honestly.
Right.
And I understand that the Heliophysics Division has a big sun celebration going on right now, the Heliophysics Big Year. Kate, could you tell us how we could get involved in this and really just celebrate our star?
Yeah, this total solar eclipse was just one event in a series of this Heliophysics Big Year, working towards Parker Solar Probe's closest approach to the sun. And we have a lot of activities where you can engage in our science and learn more about the sun. And if you want to know more, you can find us on social media at NASA Sun.
Fantastic. Wonderful. Thank you so much, Kate, for being here with us. It was really special to share this moment with you.
Thanks, Kate. It's nice to be here.
And Gina, this has been an honor. I mean, my goodness, to have the annular eclipse with you, then to share this total solar eclipse with you.
I know.
Thank you so much. And do you have any final thoughts?
This was amazing. Annular was great, but to hear the energy here,
the total was
so
just
great
a whole nother level.
Both of you,
Yeah.
Once again, thank you for having me.
Absolutely. And a big thank you to the city of Kerrville, Texas, the Parks and Rec team, and all the people that made today's incredible event possible. I also want to thank our telescope operator Catherine Troach, for those great views of totality here in Kerrville. Folks, That is a wrap from Kerrville, Texas. Back to you in Cleveland.
Thank you to Hira and Gina, and also Kate Calvin. And now check out who we have here at the host desk, the Pastronaut himself, Josh Dobbs, who just signed on as quarterback for the 49ers. How do you feel about that?
I feel good. It's exciting times. Obviously, I spent a couple years here in Cleveland. Got a chance to have some fun over at NASA Glenn during my time here. So it's cool to be back and taking the Eclipse class here in Cleveland. But looking forward to the future in San Francisco. I know NASA's doing some great work out there on the West Coast, so we'll be able to stay tuned to that as well.
Yeah, so for people who don't know, the Pastronaut nickname comes from some incredible plays you had last year, and also you have a background here with us at NASA with some externships, but also you're an aerospace engineer. So how did it feel being back here specifically in Cleveland to watch the total solar eclipse?
It felt really good. When this event was put on my radar about a year ago in last off season, they're like, hey, the eclipse is coming straight through Cleveland. We'd love to have you here. It's going to be a once in a lifetime event to be able to experience it, especially right here on the beautiful Great Lakes, and obviously have some great weather today. So I marked on my calendar a year ago, and to make it back here and take it in, and get a chance to hang out with the city I spent 2 years in, it's been great. I think the biggest thing that I've enjoyed is just seeing the interest from the city of Cleveland and how many people traveled here to take in the event today, and to be able to then also go learn about the future of NASA and the future of space exploration as well at the same time. It's a once-in-a-lifetime opportunity to take it in, and it's been an honor to be here.
So, Josh, NASA is really committed to inspiring the next generation through discovery. Do you think maybe we created a few new future scientists and engineers here today?
I think so. There's a wealth of youth walking around here and taking in not only, obviously, the blow-ups and the displays outside, but also the Great Lakes Science Center inside, and just seeing the history of the space program. I think that gives them perspective. And so that's just like NASA, that's been my approach. I think the youth, obviously, is the next generation. They're going to have a tremendous impact on the world, and being able to inspire the youth out here and the youth across the country that if you have interest in STEM and also are really good at sports, you don't have to split your eggs into.
Yeah,
you don't have to split up your eggs, right? You can go out, put all your eggs in both baskets, and work hard to achieve those goals and dreams.
Now, Josh, we have time for one other question. It's the most important question we're going to ask you.
Okay.
Who was the star today? Was it the sun, the moon, or the earth? Say the right thing, Josh. Say the right thing.
Drum roll. The star of the day was the moon. I gotta go with it. I gotta go with the moon.
I agree. I do. All right. Well, I appreciate your honesty. Right. I appreciate your honesty, and I really appreciate you being here. Thank you so much, Josh, and it was great to have you here with us.
Thank you guys for having me.
All right. So we talked about this controversial but friendly competition. So actually, we asked you guys to vote. We have the results of that poll right now. Let us bring it up. Whoa!
Hey.
All right. Congrats, Sarah.
Come on.
Congrats.
Thank you.
Team Earth,
Thank
26%. Team Sun, 26% as well. But Team Moon, 48%. Congrats, Team Moon.
Go
today.
Team Moon.
All right, again, thank you to everyone who participated. We were the real winners of today, though, those who got a show. But we're going to send it back over to Indianapolis for another really important interview.
Thanks, Megan. We are back here in Indianapolis. It has been an incredible day, and it is not over yet. With me, I have Jake Bleacher, the Chief Exploration Scientist for NASA. Jake, welcome.
I could not be happier to be here.
How was that eclipse for you, really quickly?
That was amazing. It's getting warm again. I still have my fleece on from when we were in totality.
That was incredible. Well, today has been all about the eclipse, all about the sun's light. And I want to pivot a little bit here because you're getting astronauts ready to go back to the moon, live and work there for the first time in 50 years. How the sunlight shines on the moon also very crucial to what we're trying to do there?
Yeah, well, just like this eclipse, it's the celestial dance between the sun, the earth, and the moon. And when we go to the moon, we'll actually have instances of eclipses where the Earth will eclipse the sun.
Wow.
So it's something to think about. But we're really interested in the lighting in the South Pole. Our Artemis 3 mission will land astronauts at the South Pole. And there, because the moon has almost no axial tilt, the sun is always right along the horizon.
Wow.
And so high peaks have sunlight more than normal amounts of time, and low depressions have almost no sunlight or never see the sun. And so we think there might actually be water trapped there.
Incredible. So one thing that we've talked a little bit about on the broadcast is space weather. And space weather is really important to understand, especially when it comes to the safety of our astronauts. Can you describe how the instruments Ursa and Hermes are actually helping keep our astronauts safe?
Yeah, Ursa and Hermes are payloads, science instruments that we'll have on our gateway. Gateway is going to be a station, a research station that orbits the moon, and astronauts can stop there on their way to the surface of the moon. And these payloads or these science instruments will be there to basically detect what the solar weather is like, what we call space weather. So that radiation that our astronauts will live in when they're actually there. So understanding your weather is the best way to be prepared for it.
Absolutely. Well, you've given us a lot to be excited about. Jake, thank you for being here on this incredible day.
I would not have missed it.
Well, folks, that is all we have from Indianapolis. Thank you for joining us. It has been a wild ride, pun absolutely intended, and we've had an amazing time. So from all of us here, back to you guys.
Thank you, Lauren. I did enjoy your pun. And now back here in Cleveland, we are joined by Jimmy Kenyon, director of NASA's Glenn Research Center. Thank you for joining us and for hosting us, really.
Absolutely. Thanks for having us here.
Well, so yeah, Glenn Research Center is right here in Cleveland, just down the road. The only NASA center in the Midwest, the only one in today's path of totality. Literally everything aligned for us to get a great show here.
Absolutely. And it has been such a great show here. You could not have asked for better weather, and it's springtime in the Midwest. That's always a little bit of a debate, but you could not have asked for better weather. What a great outing. We're here with our partners at the Great Lakes Science Center, and which hosts our visitor center, so where the people are, and just a great opportunity to have everybody here and connect them with what we do.
Yeah.
Yeah, you hosted this wonderful 3-day event here and invited the community and all your visitors in to come and explore and learn a little bit about Glenn. Why was that important to you?
It's important, but, well, as you know, having a total solar eclipse pass over your community is, for most people, a once-in-a-lifetime opportunity. But to have a total solar eclipse pass over a NASA community like Cleveland, that's even more rare. But what it does is it creates such a great opportunity to connect people with what we do. Everybody is here paying attention to our planet, paying attention to the moon and the sun and how all of these things work, our solar system and our universe. And that just gives us a great opportunity to say, this is what we do.
Right.
And connect people with that. And you can't pass that kind of an opportunity up.
Right. And speaking of all, like you said, the science, all this discovery that we're enabling today by the eclipse, let's talk more about the science, I know that nothing flies without Glenn. That's what you love to say, Jimmy.
That's right.
So can you explain the center's critical role within NASA?
At NASA Glenn, we work on aircraft propulsion, spacecraft propulsion, power for both aircraft and spacecraft, communications. We also work on materials and testing in extreme environments, but our core competencies are power, propulsion, communications. No aircraft and no spacecraft flies without those three things, and they never will. And so NASA Glenn is literally part of virtually every NASA mission.
Well, Jimmy, thank you so much. I really appreciate you being here and, again, hosting us. This was a wonderful event. I know so many people joined us here and really enjoyed it because we were watching. We were looking out at the crowd. Lots of smiles. So really, thank you so much. You and the Great Lakes Science Center.
And thank you for being here and being part of this with us and really putting NASA and NASA Glenn on the map here for us.
Thank you, Jimmy. Thanks so much. Have a great day. All right, and a big thank you to our whole team positioned across the path, from our correspondents to our experts and our telescope operators. We couldn't have done it without all of you. And Sarah, as we're taking, again, this aerial shot of the Great Lakes Science Center, so beautiful. Such a wonderful way to experience my first total solar eclipse, and I hope you had a good time too, because I know this isn't your first total solar eclipse.
No, this is my second, but it was really great and special to be able to experience it with you and all the folks here.
Yeah, we did notice that people right after, the people were like, whoa, they were trying to get out here. There's a lot of really fun events happening in Cleveland, so there's a lot of people in downtown, so I hope that they took some time to look up today and really enjoy what they saw.
Yeah, and not only all of the great views that we had, but we also really did some cool science today too.
Yeah, really, really cool science, and actually, yeah, let's talk about that. NASA's heliophysics big year isn't over yet. We had the annular eclipse, then we had the solar eclipse, and now talk to us about what's happening in December.
Yeah, coming up on Christmas Eve, in fact, Parker our solar probe will make its closest approach to the sun, 3.9 million miles, which still seems like a long way to me, but apparently that's actually pretty close.
Yeah, I can't believe that's happening. Again, just that it's all, we've been saying this all day, aligning. Everything is aligning for us to have a beautiful show. And so, yeah, Sarah, again, thank you so much. We watched this together, race across Mexico to Maine in only an hour and 28 minutes. And again, we have so much more to look forward to. So we hope you all stay with us as we continue studying our sun and how it affects us, from all of us here at NASA, where we make air and space available for everyone. Thank you for watching, and enjoy the rest of your day.
It's a new era of pioneers, star sailors, thinkers, and adventurers.
3, 2, 1, 0. All engine running.
Let's go.
Look how dark it is.
Look at that.
Look how dark it got.
This is, I'm geeking, man. I'm not gonna lie. Like, this has me really. Look at my phone, Vato. It looks like a black hole. Come look at my phone. Look at this.
Oh, damn.
Look at that.
I can't do that, Vato.
Look, I can get closer. No, that's the fastest way. Or for this guy.
Damn, that's nice.
Isn't that insane? And I go really bright.
That's it with me. I gotta look at that.
Dude, this is so cool. I'm geeking. Oh my
Oh
god.
my god.
Look how dark it is.
The stars are coming out.
Oh my god.
Look how dark it is.
Look at that.
Look how dark it got.
This is, I'm geeking, man. I'm not gonna lie. Like, this has me really. Look at my phone, Vato. It looks like a black hole. Come look at my phone. Look at this.
Oh, damn.
Look at that.
I can't do that, Vato.
Look, I can get closer. No, that's the fastest way. Or for this guy.
Damn, that's nice.
Isn't that insane? And I go really bright.
That's it with me. I gotta look at that.
Dude, this is so cool. I'm geeking. Oh my
Oh
god.
my god.
Look how dark it is.
The stars are coming out.
Oh my god.
Look how dark it is.
Look at that.
Look how dark it got.
This is, I'm geeking, man. I'm not gonna lie. Like, this has me really. Look at my phone, Vato. It looks like a black hole. Come look at my phone. Look at this.
Oh, damn.
Look at that.
I can't do that, Vato.
Look, I can get closer. No, that's the fastest way. Or for this guy.
Damn, that's nice.
Isn't that insane? And I go really bright.
That's it with me. I gotta look at that.
Dude, this is so cool. I'm geeking. Oh my
Oh
god.
my god.
Look how dark it is.
The stars are coming out.
Oh my god.
Look how dark it is.
Look at that.
Look how dark it got.
This is, I'm geeking, man. I'm not gonna lie. Like, this has me really. Look at my phone, Vato. It looks like a black hole. Come look at my phone. Look at this.
Oh, damn.
Look at that.
I can't do that, Vato.
Look, I can get closer. No, that's the fastest way. Or for this guy.
Damn, that's nice.
Isn't that insane? And I go really bright.
That's it with me. I gotta look at that.
Dude, this is so cool. I'm geeking. Oh my
Oh
god.
my god.
Look how dark it is.
The stars are coming out.
Oh my god.
Look how dark it is.
Look at that.
Look how dark it got.
This is, I'm geeking, man. I'm not gonna lie. Like, this has me really. Look at my phone, Vato. It looks like a black hole. Come look at my phone. Look at this.
Oh, damn.
Look at that.
I can't do that, Vato.
Look, I can get closer. No, that's the fastest way. Or for this guy.
Damn, that's nice.
Isn't that insane? And I go really bright.
That's it with me. I gotta look at that.
Dude, this is so cool. I'm geeking. Oh my
Oh
god.
my god.
Look how dark it is.